Hello and welcome to Module 17 in our C language series. This module is going to focus on queues, stacks, linked lists, and trees. However, in today's session, we're going to focus solely on the queue. Before we get down to discussing the queue, just a brief introduction. We've reached a certain point in our learning of C where we can answer certain questions. What do programs actually consist of? And if we think about it, there are two things. We have the algorithms and we have the data structures. What constitutes a good program? Well, one could say that it's a good blend of algorithm and data structures that would make for a good program. What determines how information is organized and accessed? So when we're talking about, for example, how information is accessed, it could be through disk, right? It could be via a remote server. It could be via keyboard input. All that would depend on the programming problem itself. How close is the logical concept of a data item bound to its machine representation? So if we talk about the integer data type, this is tightly bound because remember, we know the integer is 4 bytes and that's exactly how it is represented by the machine. Similarly, the character is 1 byte. Again, there is a tight binding between the logical concept of this data item and its machine representation. But when we talk about floats, and we've seen this in module 5, and you can go and review that if you like, we spoke about how floats are represented by the machine using the IEEE 754 form of representation. And so this provides for an abstraction between the logical concept of the data item and its machine representation. Right? Similarly for arrays and more so for structures, and therefore we can say that the more the level of abstraction, the less tight is the bond between the logical concept and the machine representation of a data item. And so instead of focusing on this bond, it is the norm to focus instead on the sequence in which data is stored and retrieved, which brings us to the discussion of what the data engine is. And it is the data engine that controls the way information can be accessed by a program. There are 4 data engines. We have a queue, a stack, a linked list, and a binary tree. And we will look at each of these separately in detail in later sessions. But as I said earlier, today we focus on the queue. Important to remember that each of these data engines performs a specific storage and retrieval operation. Now let's talk about the queue. And you may have stood in many a queue, right? And we know that each of these people will be attended to in a or on a first come, first serve basis. And the same goes when we talk about the queue in the context of computers. If you're asked what is a queue, it will be something like this. We have one task placed into the queue, then the second, the third, and the fourth. Right? And once the first task is completed, that's removed from the queue. So also second, third, and fourth. This is, as we may know already, in a first in, first out order. Right? It's kind of opposite to the stack. And we'll talk about the stack in more detail in the next session. Coming back to the queue, no random access is permitted with regard to the queue. How would this work in code? We would need functions, of course. We could have a queue store function in order to add the task to the queue, and then a queue retrieve function to remove the task from the queue. Important to note that the retrieval operation removes an item from the queue and destroys it. Why is it destroyed? Because remember, the queue is a memory concept. So unless we store that task somewhere or store the information somewhere, is going to be lost. Now, where are queues used in terms of programming? They could be used in simulations. And what is a simulation? Well, it's creating a digital model of something real. Right? So you could simulate, for example, the landing and taking off of airplanes. You could have a landing queue and a takeoff queue. Right? Similarly, if you make a call to your bank or to your internet service provider for that matter, you would get a message saying that your call will be attended to by the next available agent. That too is a queue system. It's also used in event scheduling, like PERT and Gantt charts, and you may know that these are what are used in project management. So when we talk about a real estate construction project, for example, we would have tasks ranging from laying the foundation to landscaping. And you obviously can't have landscaping done before the foundation is laid. And so you would have a queue, right, wherein tasks have to be performed in a certain order, right? The same first in, first out order. Queues can also be used in I/O buffering. And here we can look at the example of the printer. You could give many print commands to your printer, and all the documents that you want to print would be placed in a queue, and they would be printed out again in a first in, first out order. Now let's write some code. Create a simple appointment scheduler program. This program should allow you to enter a number of appointments. As each event is performed, it should be taken off the list. The description of the next event is displayed. The program should also provide a list of the events on screen. Limit appointment description to 256 characters and number of appointments to 5. Right? But how do we write this code? So let's look at the functions that we would require. The main function would ask the user whether they would like to add, list, delete tasks, and call those appropriate functions. Add task would loop while the task entered is not null and the list is not full. Remember, our list essentially would be an array capable of holding 5 tasks or 5 appointments. List task would use a loop to display all tasks or all appointments on the list. Delete task, the tasks would be taken off the list once they were completed or appointments attended to, and these would be removed in a first in, first out order. Store task will be called by add task to store the task added in an array. So let's now go to code blocks and we can start a new file. And so we start with hashtag include stdio.h and then hashtag include stdlib.h and then hashtag include ctype.h because we will use a toUpper function, and we need string.h as well as also stdbool.h. Right? Now we'll use a hashtag define maximum 5 appointments. Okay, you can change that later. Functions will be add tasks, and the next one will be store tasks, and that will take char star q, right? Because remember, we're passing the task in there. And then list tasks, and delete tasks, and retrieve tasks. So this is going to return a character pointer because it's going to return a task, right? So task retrieve, no parameters. And we have some global variables in start index, comma, retrieve index, and bool type list full. Okay, then we need char star task list of max. It's a double dimensional array for all the tasks or the appointments, right? Now we have our main function, and here we'll have start index equal to 0 and retrieve index equal to 0. Char choice, we'll keep that as 80 bytes. This is for user entry for the choice they want. In size equal to size of task list, right, divided by size of task list of 0. Okay. Then list full boolean type will be initialized to false. I will use memset. Okay, and we'll send into memset task list \0 and size as arguments, right? So we'll initialize task list to null, all the spaces that is within task list, and then while 1, eternal loop there, printf, and then get s choice. Once the user puts in their choice, then we can first of all convert it to uppercase. So choice, star choice equal to upper of star choice. Okay, then switch star choice, and now we can check the value of choice entered. So case A, right? We'll call add task break. Case L, we'll call list tasks and break. Then case D, we will call delete tasks and break. And then case Q, we can just exit. Okay, that completes the main function, right? Once that is done, next function is add tasks. And within this function, we'll have char task to add. We've got to restrict that to 256, right? And then char star task added. Now we'll have a do while loop. So do, and within this loop, printf %d, right, comma, start index +1. So start index will be 0 first, so that will be printed out as 1 the first time this do while loop runs. Scanf, and we're going to allow entry until the enter key is pressed, comma, task to add, right? Then flush, and we check if start task to add is equal to 0, right? Then break. Otherwise, we use malloc now to allot memory. So task added equal to malloc, and we'll use strlen of task to add. Okay. Then if not task added, which means malloc returned a null, then printf out of memory and exit 1, right? Or you can just say return, which will return to main. Now, if malloc does not return a null, we can use memcpy, or you can use strcpy if you like, right? So I'm going to use memcpy, and we're going to see here task added, comma, task to add, comma, strlen of task to add, right, +1. Okay. Then if star task added, which means task added is not a null, then we can store the task. So store tasks, and we pass task added, right? And we do this while star task added is not equal to null and not list full, as in list full is false. So that completes this function. Next function is store task. Star q is going to be the parameter here, and within this we check if start index is equal to max, right? Then printf list full, and list full equal to 1 or true, and then return. If not, then task list of start index equal to q, right? So we are storing in the queue essentially the task. And then start index ++, right? So we're ready for the next task to be stored in the queue. And that completes store tasks. Next function is list tasks. And within this function, we just need counter or counter equal to retrieve index, right? Counter less than start index. Okay, counter ++. And all we'll do here is just printf task %d, right? And then %s \n, comma, counter +1, comma, task list of counter, right? And that's all. Then we have the delete task function. And within this one, we'll have char star task to delete. We'll use this to catch the return value of the retrieve function. We say here if task to delete equal to task retrieve, then that returns a null essentially, which means task to delete is null, then return, right? Otherwise printf %s \n, comma, task to delete, right? And that completes the delete task function. And now we have char star task retrieve. And within this function, we say if retrieve index equal to start index, then printf, right? And then return null. Okay, otherwise retrieve index ++ and return task list of retrieve index -1. Okay, and that's all. So let's run this now and see the results. No semicolon there. Add. Put in some appointments. And there you have the list of tasks. And you can see it's taken in just those 5 tasks or 5 appointments. Right? Now you try to delete. And you see this is in, first out order. The first appointment is complete. Delete again. The second one. Delete again the third one. Now if you try listing, you'll get only the last 2. Right? So this is how this works. Right? I hope this is clear. Any questions? Post in the comments. Moving on now to the circular queue. So what is a circular queue? So what we saw just now in the program we wrote is a linear queue, right? Where we have the start index moving along and then the retrieve index kind of chasing that start index. The program ends when the start index reaches the last appointment or the last possible appointment, we can say, because we have maximum 5, right? But we could have it so that when start index reaches the last appointment possible to be stored, we can reinitialize it back to 0, right? So both of these move back to 0 and we can keep storing appointments then, right? The program doesn't have to end. And that is what is called a circular queue, right? So that will be something like this. You have your max, and then you have the 0th, and you have the different element numbers or positions and you're storing values there. This is on the basis, of course, that we're putting items into the queue, but we're also making sure they're removed, right? So when we reach the max, the 0th appointment or the 0th number would have been removed and we could store a new one, right? Or the task at the 0th position could be removed and we store a new task. And so we can continue. Now, where is this circular queue concept used? It's most commonly used in operating systems. Why? Because it's used to store information read or written to the disk or the console, right? You could also think of it as being something like this. You're typing on the keyboard, but the processor is busy doing something else. So what you're typing on the keyboard goes into a buffer. And when the processor has some idle time from the buffer, whatever you typed in is taken and processed, right? So now I'm going to show you a demonstration through code as to how this circular queue concept works. So I'm going to go back to code blocks now. You don't really need to type in this program, but if you want to, you can. So we start with hashtag include stdio.h and then hashtag include stdlib.h and then hashtag include conio.h. Okay, hashtag define max 80. Char r of max plus 1. Right? And we have int start index equal to 0 and int retrieve index also equal to 0. Okay, functions void cq store char cq and char cq retrieve, and that's going to take no parameters. Our main function, and here we have int I char ch. Then we have a for loop ch equal to a space comma I equal to 0, I less than 32,000 and ch not equal to char of 13, right? That's the enter key essentially, I plus plus. And within this loop we check if key be hit, right? So if a key is pressed, then we use getch. Remember, getch does not echo characters on screen, and we pass that character to cq store to be put into the queue. Okay, otherwise we printf %d comma I, just printing out that number, right? And then if ch equal to char 13, then while ch equal to cq retrieve, right? So if ch that is returned is not equal to the return key that was pressed earlier, then we just print the character. So printf %c comma ch, right? And then printf \n. Okay, that ends the main function. Now we can type in the next function, which is cq store. and that has the parameter coming in CQ. Within this function, we say if start index plus 1 is equal to retrieve index, which means our list is full, or it could also be that, so or start index plus 1 equal to max, right? And not retrieve index. So retrieve index is 0. Right? Then we printf list full and return. Otherwise, ar of start index equal to CQ. So we're storing the character in the queue or putting it into the queue, start index plus plus, right? If start index equal to max, we will now want to create that circular queue. So start index equal to 0, right? And that completes CQ store. Now CQ retrieve. And in this function, no parameters. We check if retrieve index equal to max, then retrieve index equal to 0, right? We check if retrieve index equal to start index, then return 0. Okay, otherwise retrieve index plus plus and return ar of retrieve index minus 1. Okay, so I hope that's clear. And that completes the code. So let's run this now. Okay, so CQ retrieve should be returning a character, right? So char CQ retrieve, that's the error. Now you see I will type in something, and when I press enter, you'll see whatever I typed in at the end. So this is demonstrating how a circular queue works. Right? The processor was busy printing out these numbers, and therefore all the characters I was typing in were put into a queue. They were displayed only once I pressed the enter key. Okay, so I hope that's clear. So this actually ends our session for today. In the next session, we'll talk about the stack. Till then, take care, stay safe. Bye.